V represents what? Say angular velocity, angular velocity is omega, velocity is V, but only magnitude relationship, that means speed. Particle moves from initial position A to final position B. It has covered small distance dl and small angle d theta. In how much time? dt time. As per definition, speed or velocity v is equal to distance covered over time. dl is equal to what? Length of arc, angle d theta, r. D theta is defined as ratio of length to radius. So dl is equal to what? dl is equal to r d theta by dt. D theta by dt is what? Angle covered per unit time is omega. So v is equal to r omega. 2 minutes to complete. Refer to the book, numerical number 16. Page number is 2 by 167. Numerical is wheel of an automobile is rotating with 4 rotations per second. How many rotations? 4 rotations per second. So frequency is how much? 4. Number of rotations per second is termed as frequency. So 4 rotations per second. Find its angular velocity, first part. Second part, if the radius of the wheel is 50 centimeter, find a linear velocity of a point on its circumference. So there is a wheel, of a certain radius r. Given is what? Frequency is given, 4 rotations per second, 4 hertz. The radius 50 centimeter, 0.5 meter. Find A part omega, B part speed of point P. Different points will have different speed. For example, this point P will have some speed. This point Q will have a different speed. Angular speed will remain same. If you move from this position to this position, all the points move through same angle. Angle covered by P and Q is the same, but distance covered is not same. P covers more distance, large radius. Q covers less distance. So here the question is speed or velocity of a point P, that is at the end. So you have to find out V of P. Time with you is 2 minutes. Try. first part. Anyone with the answer? Omega is equal to, you can write 2 pi total angle covered by total time taken, 2 pi by t or 2 pi f. Yes, 2 pi into 4 cycles or rotations per second. So what you get is 8 pi. This 2 pi is what? Radian. What is the SI unit for omega? Angle covered per unit time. 8 pi radian per second. How many of you got this answer? First part. Right. Try B part. Formula is written on the board. For B part, formula is written on the board. V is equal to, yes, formula R omega. V is equal to R omega, or you can say 2 pi R divided by T, whatever way. R is how much? 0.5 meter. R is 0.5 meters. Omega is 8 pi radian per second. What you get is 4 pi. What is SI unit for speed or velocity? Meter per second. So 4 into 3.14. You can write this 4 pi as it is. Yes, here it is 4 pi. It is 400 pi centimeter per second, but we are writing it in meter per second. So this was your numerical number 16. As an example to question number 4. Question number 5. Notes question number 5. Angular acceleration. Second part of the same deals with the relation of angular acceleration and linear acceleration. How do you define acceleration? We have defined in chapter number 2. Yes, acceleration is rate of a change of velocity with time. Here we have to define A part, question number 5. A part, angular acceleration. Yes, the definition is angular acceleration is defined as the rate of a change of angular velocity with respect to time. Rate of change of angular velocity with the time. That means what? d omega by dt. Symbol for the same is what? Alpha? Only magnitude. So in the first part, we deal with only the uniform circular motion, means a particle moves with the constant omega. That's first part you will deal with in this particular chapter. But as per definition, if omega remains constant, for example, fan at present, it is moving with the omega remains a constant. So if omega is constant, rate of change of omega with the time is 0. So at present, fan under steady rotational condition, angular acceleration is 0. But when you switch on, then what is the status? Omega increases. There is a rate of a change of omega when you switch on or switch off. First part. Then relationship. There's the second part, part B, relationship. The relation of alpha and A. A is equal to d dt of V. V is equal to what? R omega. If R is constant, d omega by dt. D omega by dt is what? Alpha. So A is equal to R alpha, where A is linear acceleration, R is radius, and alpha is what? Angular acceleration. Units. SI unit for this, yes. Omega, angle per unit time. This is time. So it is a radian per second divided by second. What you get is radian per second square. Dimensions, yes. Dimensional formula for angle is what? M0 L0 T0 by time square T minus 2. Time with you is 4 minutes to write. 4 minutes to write. Try numerical number 17, 17. Result is A is equal to R alpha. Question is, the angular velocity of a particle moving in a circle of radius 50 centimeter is increased in 5 minutes from 100 revolutions per minute to 400 revolutions per minute. Find angular acceleration and linear acceleration. What is given is, particle is moving in a circle of what radius? Yes? 50 centimeter, 0.5 meter, first part. And it was, the wheel was rotating at certain number of rotations. How many revolutions per second? Per minute? 100 revolutions per minute. Agreed? 60 seconds. So this was the initial status. And what we have done is, after some time, after how much time? 5 minutes, it changes to new speed. The speed increases. How much? Second case, the same particle, 400 revolutions by 60 seconds. This is a photograph at t is equal to 0. This is a photograph at t is equal to 5 minutes. This is a case of a regulator. Regulator, fan regulator at number 1. It is 100 rotations per minute, say RPM, RPM, rotations or revolutions per minute. And you change it to 4. Now it is 400 RPM. It has taken some time to shift from 100 RPM to 400 RPM. This is a case of mixer grinder when you change the speed. This is a case of a washing machine when you can change the speed. Number of machines where initial RPM is given, you use a regulator, a switch, a rotational device to increase its rotation from 100 to 400. And what do you want to find out is, yes, find A part, yes, angular acceleration alpha. B part, linear acceleration A. Time with you is 2 minutes to try. Find alpha. You can refer to the definition. Alpha means what? Anyone with answer, please? 1, 2, 3, 4. As per definition, angular acceleration alpha is equal to change in angular velocity over change in time. Final angular velocity, or omega 2 minus omega 1 over time. It is equal to 2 pi f2 minus 2 pi f1 over delta t is equal to 2 pi is common. F2 is how much? Yes, 400 rotations per second divided by 60 seconds minus initial frequency f1. Yes, 100 by 60 divided by time taken. How much? 5 minutes means, yes, 1 minute is 60 seconds. 5 into 60, 300 seconds. So it is 300 seconds. Now SI unit for angular acceleration is angle, radian. This is radian per second divided by second, radian per second square. Solve and come out with answer. Answer has to be in SI units, radian per second square. Yes, answer please. Pi by 30 radian per second. How many of you are getting pi by 30 radian per second square? Pi by 30 radian per second square is the answer. Solve B part. 1 minute to solve B part. Linear acceleration A. The relationship alpha you have solved. Alpha you have solved. Earlier it was not known. Now you know it. It is pi by 30 radian per second square. How do you find A? Yes, The relationship between A and alpha is what? A is equal to R alpha. R is equal to 0.5. Alpha is equal to what? 5 by 30 radian per second square. SI unit for acceleration is meter per second square. So it is pi by 60 meter per second square. SI units. Our answer is in SI units. In case you want it to centimeter per second square, then change 1 meter to 100 centimeter. Just to tell you the answer. Otherwise, this is correct. SI units. This is from where you start the experiment. Initial. T is equal to 0, speed is termed as u. When you start, the time is 0. When you start taking observation, time is 0. That is the starting point. That is where T is equal to 0. So if you take this to be 1 minute, then it is after 5 minutes, then it will be 6. So it is your choice. T is equal to 0. It doesn't mean that is at 12 o'clock. When you start the experiment in the lab, take that time T is equal to 0. Question number 6. Notes question number 6. Define time period, frequency, relationship between T, F, omega, F. We have already covered it. Time period, frequency, omega and F relation. First part, time period, T. Yes, time taken by the particle to complete one cycle. A particle starts from this point, completes the cycle, comes back to the same position. Time taken to complete one cycle or circle, T. This is first part. Second, frequency, number of rotations per second. If a particle moves 4 times in 1 second, frequency is 4. If a particle moves 5 times in 1 second, frequency is 5. So relationship between frequency and time is what? 1 by T. Third, angular velocity, omega, we have already dealt with. Omega is what? Total angle covered. When this particle moves from this position, comes back to the original, what is the total angle covered? 360 degree or 2 pi radian. So angle covered is 2 pi radian. In how much time? T seconds. So it is 2 pi by T, or 1 by T is equal to what? F. 2 pi F. The units are radian per second. Time with you is 3 minutes to complete.